In this video, I'm going to take you through the 2-2C lesson. Please fill this out in your module. Feel free to pause or rewind the video if I'm going too fast. We're going to continue looking at linear equations and graphs. We're going to focus on some of the things that we saw before break, which is non-proportional relationships, which means that most, if not all, of these graphs are going to be lines, but not start at the origin. Number one says Bert, the bumblebee, is 2 inches away from a flower. Then he suddenly flies away from it at a rate of 3 inches per second. We're going to fill out the table in the graph and answer some questions. So this means that the bumblebee starts 2 inches away, and each time is an additional 3 inches away, which means adding 3 we would get 5, and adding 3 we would get 8, and adding 3 we would get 11. Next thing we're going to do before we fill in the third column is we're going to add some margin work into our table to show that this column every time is going up by 1. We haven't done this in a lot of the tables, so be sure to include it on this one, as this is our first or one of our first non-proportional tables. And the y column goes up by 3 every time. And so B says state the rate of change. Well, the rate of change, or the ROC, as I sometimes abbreviate it, is the change in y over the change in x, which is the rise over run, which is, well, we know it is 3, because we actually just found what the rise was, even though we didn't have the graph, over 1, which means that the rate of change is 3. And we'll also see that in a minute when we graph it. And it technically does say to look for it on the graph, but it's nice to also see that you can identify this in the table. It's also handy to do that to make sure that we understand the difference between the change in y over change in x and y over x. Because now when we do y over x, 2 over 0, which was undefined, we see we get different values. 5 over 1 is 5, 8 over 2 is 4, and 11 over 3 is 3 2/3. So we see that y over x no longer stays constant in these non-proportional relationships, but there is a rate of change or a change in y over change in x. Next, we're going to graph it. We'll take our points. We will start up at 0, 2. And then we'll go to 1, 5. And 2, 8. And we will connect these points, and we get our non-proportional linear relationship. C says at 0 seconds, how far is Bert from the flower? Circle on the graph and state the ordered pair. Well, Bert is 2 inches away. As an ordered pair, that is 0, 2. On the graph, that is this point here. And we also call this point the y-intercept. It's where the line crosses through the y-axis. We can think of almost like an interception. If this were the path of the football and this were the opposing team catching it, it's where these cross paths. Intercept, not intersection. One other thing before we get too far into this problem, if we go back to, we actually never showed the rate of change on the graph, so we'll do that right now, which is that this was up 3 and over 1, just like it was in the table. Next it says on letter D, this situation is represented by the equation y equals 3x plus 2, so our goal is to figure out how they got this. How is the rate of change shown? Well, the rate of change was 3, and it's the coefficient of x. So 3, which was the rate of change, which is the coefficient. Followed up by how is Bert's initial distance shown in the equation? So that was our initial value known as b, which was 2. We use the variable b to represent this initial distance. And we'll also clarify that in the paragraph below. And it is the constant. In the equation. We'll also add to it's the number added to the end of the equation. So we used the word constant a while back. Constant means the number that is not have a variable attached to it, and it was 2. And this is the y-intercept, and we are going to start to use the variable b to represent y-intercept. If you need to pause this, now is a good time. I'm going to go down, though, if you're ready for the paragraph below, which states, to summarize this example, the equation for any non-proportional relationship relates x values to y values through multiplication and addition. The equation is in the form y equals mx plus b, where m is our rate of change. So we're going to start to use that as our variable for rate of change. And b, there's that variable that I started to use, is the value of y when x equals 0. In the situation above, feet and time are not proportionally related because the equation y equals 3x plus 2 relates time to inches by multiplying the number of seconds by 3 and adding 2. The initial value is the y-intercept. And the y-intercept is the point where the graph crosses the y-axis. Now we're going to look at some smaller scenarios, as this page involved all one problem. So now we're going to look at 2 examples, and we're going to practice building these equations where they're not going to build them for us. It says, Jumpers R Us charges $10 per person per hour to jump and $3 for the required sock purchase. State the rate of change. That's my M. Let's put M. B, if Jane jumps for 0 hours, what is her cost? Well, that actually is literally the B. This is my y-intercept. This was my ROC. C, write the equation in the form y equals mx plus b. In D, we have a follow-up question. So for A, our rate of change is $10 is added every time. Our initial amount just to get in the door for 0 hours is $3 because we need to buy the socks even if we don't end up jumping. We place this into our equation where M goes there and B goes there, and we don't forget the variables X and Y. Part D, we will use our equation to then answer the question, which is, for 4 hours, what's the total cost? And we said that X was hours. Number 3, we'll do the same thing. I would suggest pausing the video on number 3 and trying this one, and then checking it with what I got. If you feel like you really need to see it done, then feel free to do it with the video, but it is very similar to number 2. So pause the video and unpause when you're ready. Number 3, state the rate of change. That's my M. Initially, how much money does Andy have? That's my B. So Andy has $100 in the bank and saves $5 per week. So $5 per week is the rate of change after every week. The initial amount is 100, and that would make the equation y equals 5x plus 100. Using the equation, we'll then answer the follow-up question, which is y equals 5 times 12 plus 100, which is y equals 60 plus 100, and y equals 160. So Andy has $160. Look at number 4, and that will take us to the end of this first video. Feel free to pause and go back, though, to the other parts of this if you have some questions. Directions for each non-proportional graph: state the rate of change. That's my M. Circle and state the y-intercept. That's B, and write the equation. I like to start with B, which is the easiest thing to find. My y-intercept or starting amount is 1. So I know currently my equation is y equals something x plus 1. Next, I'm going to look at my graph and draw in my triangle and carefully count what is my change in y, which is up 2. I like to put plus 2 there. So this is rise over run, which is 2 over 1, 2, 3, 3. So 2/3, which means my equation is y equals 2/3 x plus 1. There'll be one more video that wraps up the 2.2c lesson.